Okay, Roman numeral 2, we're going to identify even and odd functions from an equation now. Let's take a look at part A. We have y equals 2x to the 6th minus 3x to the 4th. So what we're going to do is we're going to run a test here. We're going to run a test with that f of negative x. So if I take my negative x and I put it into this equation, like so. And we just kind of run through the motions here, right? This is going to be 2 times. And now negative x to the 6th power, that even power, that is going to be a positive x to whatever that even power is. And over on the next term over here, we're going to minus 3. And then we have negative x times negative x times negative x times negative x 4 times, right? You're going to have x to the 4th. And we notice that f of negative x actually equals the original function f of x. That means this is an even function, and if you want to be super cool, you can claim it also has y-axis symmetry. Okay, let's move on to part B. Let's say we got y equals 2x plus x. All right, that's the absolute value of x, by the way. And we want to test f of negative x once again. All right, so I'm going to put in my f of negative x. That's going to be 2 times a negative x plus absolute value of negative x. And when we apply this, right, when we go through these motions, this is actually going to be a negative 2x. But the absolute value of negative x is simply x. So this is going to be plus absolute value of x, if you will. Now, if you take a look at this, notice this does not match the original, right? F of negative x does not equal f of x. And also f of negative x does not equal the negative, we'll say negative 2x minus the absolute value of x, which would be the negative f of x. So we're going to say that this is neither, all right? This is neither even nor odd. It doesn't satisfy either of the conditions. All right, let's go on to part C. Last but not least, let's plug in our negative x here. And if we do that, we've got 4 times negative x over absolute value of negative x. This is an equal sign, by the way. So f of negative x equals, and then on the numerator I'm going to have negative 4x, and the denominator I'm going to have just the plain old absolute value of x, right? Because the absolute value of negative x is the absolute value of x. And we notice that I could actually put that negative right in the middle. I know it's in the numerator, but I could put it right in the middle of that fraction bar. And I could write this like this, which is negative f of x. I'm going to put that over on the side, is negative f of x with an exclamation mark. Therefore, this function is odd. And if you were to graph it, you would notice that it does have origin symmetry. All right, let's move on to Roman numeral 3, and we're going to find the average rate of change here, okay?